starting the recording now. And also I can share my screen. I'll share the entire screen so that, because today I'll be discussing many things which will require many applications. Okay. Let me start with today's presentation, which is okay. So I welcome everybody in this today's session on machine learning for signal processing. This is the first class, and we are discussing the overview of this course, mostly the logistics, but also the tools which you will be needing during this course to effectively learn. Okay, so some basics which you all know probably. First is the course website. So we'll be using Mookit platform for all the course executing the course. So basically all the videos will be uploaded, all the resources, slides, assignments, exams, and all the forums where you can communicate with each other, ask questions, and in that way enhance learning. Everything will be on this platform. I'll just click on this so that this is so this is the course description. Let me go through it once so that you are familiar. So first of all, this course aims at introducing machine learning techniques for various signal processing applications. So you can see the focus of this course will be on both machine learning as well as signal processing. So you have to learn both machine learning as well as digital signal processing. Both will be required. So last time when I did this course, so some students faced this problem that they did not know DSP, digital signal processing. So this time I am explicitly mentioning in the course description that DSP will be required. And if you don't know DSP, you can learn it, no problem. But if you know it beforehand, then it will be much easier. Okay, so what is DSP? Basically, DSP means you represent the signal. You have an analog signal, you sample it to get the digital version of it. So sampling and quantization, which basically means converting the continuous stream of, so converting a continuous valued signal to discrete valued signal, where the values are also quantized to certain levels. Because you know your computer is a digital computer. It cannot store numbers with infinite precision. Means after the decimal, it has to truncate. Let's say up to eight decimal places, 10 decimal places, like that. So that is called quantization. You quantize your values. So this is so you represent your signal digitally, and then you do some processing. Like mostly we'll be dealing with spectral processing. What does that mean? It means what are the frequencies present in this signal? So you try to represent this signal as sum of sinusoids. So if I give you a pure sinusoid, it's just single frequency, but your signal can be a mixture of 2 sinusoids, 3 sinusoids, or potentially so many sinusoids. But that kind of analysis is called a Fourier analysis, which is, I hope you all are familiar with. And this is the spectral processing technique for analysis and also for transforming the signals. Mostly we'll be focusing on audio signals. In this course, last time the focus was not audio signals, it was general, but this time the focus will be more on audio signals. We'll be doing other kinds of image, etc. also, but mostly it will be audio signals. Then we'll be looking at various practical, what do you say, intuitive understanding of Fourier transforms, and intuitive understanding of how to process that signal so that it carries the information what you need, and you can extract that information out very effectively. So, okay. Then the lectures will focus on mathematical principles. Yes, mathematically, the theoretically will have a very strong basis. And then there will be coding-based assignments for implementation. As I have already released in the first week's videos, we'll be using Python for programming in this course. So learn Python nicely, because all the assignments, etc., will be coding based, and Python will be used for those assignments. Because both signal processing as well as machine learning, they are based on programming. You cannot do machine learning without knowing programming, and similarly, you cannot do digital signal processing without knowing programming. So I think that is it is very well. It's very much necessary for you to know programming. But the purpose of this course is to train you in both, that you learn programming as well as theory. So I would request you to start practicing programming and Python. It will be very helpful for you. Those of you who are BTech students or UG students, of course, you will be benefited. Those who are PG students, you will be highly benefited, because these days you cannot imagine signal processing or any thesis work in signal processing without doing any programming. Programming is kind of must these days, especially if you want to use machine learning. You cannot do away with programming. So programming will be heavily used in this course. And next, prior exposure to ML is not required. This course will be self-contained. All the concepts will be taught from scratch. When I say scratch, it means this. The prerequisites are, you know some DSP, some digital signal processing, and you know the basics of programming. That is there. But you must be very good in linear algebra, probability theory. These are the very basic foundations for learning machine learning. Okay. The course will be focused on applications in audio signal processing, and the theory will be tailored towards that end. So we'll be discussing the basic theory first, like what is machine learning, linear models for learning, nonlinear models, deep models, all these things. But gradually we'll be shifting to various applications. We will try to keep it general, but to give you a flavor, we also will go a little bit deep and see the applications in various domains, which are mostly related to audio signal processing. Okay. Grading scheme, I think you've all seen. This is very different grading scheme. And also, I would like to give a word of caution here, because we are doing this for the first time. There may be some fluidity here. Means we might have to change some percentage assignment. And so still there are many issues which the institute is not very well knowledgeable of. For example, how to conduct exams, a very big issue. And we have some techniques, some methods we have thought of, but hopefully with time, institute will acquire more ideas to conduct exams in a more robust way. So that is why grading scheme is tentative. Take it as tentative. So I would request you to not depend on just end sem exam, or don't postpone your efforts. So put your efforts right from the beginning. The grading scheme is very, very tentative. And also there is a new component. There could be oral exams or viva via video chat or phone call. This is there to make sure that the grading is fair and the grading is robust. Okay, and plagiarism will not be tolerated. Cheating, copying, sharing of assignments, or um, um, copying from internet, all these things. So plagiarism will be heavily penalized. We have got several techniques to detect plagiarism. So I hope you won't do it, because you are respectable. You will maintain the dignity of the institute and the dignity of yours. So do not indulge in any kind of plagiarism. Okay. Let us go through the course content. Linear algebra, programming basics, DSP, probability theory. Okay, these are the basics. Then we come to machine learning basics, which means the linear classifiers, linear regressors. Then nonlinear part, which will be mostly dealing with neural networks. I will not be covering other nonlinear techniques like decision trees or SVMs. So those techniques we may not go into, but some techniques, yes. Like when you do probability theory, you will be looking at Gaussian mixture models. So they're also machine learning models. So we'll be looking at them, yes. But mostly our focus will be on deep learning, neural networks. So that's it. Okay, then we have some applications in audio processing, like speech recognition, acoustic event detection. So speech recognition means, let's say I'm speaking and the machine is transcribing it into text. So it's speech to text conversion. And then we have acoustic event detection, which means, so speech is for speech, like words, when you speak, that is the speech. But acoustic event is for any sounds, let's say clapping or coughing or sneezing, or like, do it, like knocking at the door, like all these sounds. So which are not speech, they are acoustic events. Somebody knocks at the door, that's an event. So how do you detect it automatically? Then speaker diarization. Speaker diarization means, let's say two people are speaking. I'm talking to one of you. So let's say I'm talking to Vikas. Vikas is the TA who is present here today to take care of any technical glitches. Okay, if you have any technical glitches, write on the chat window. Okay, so Sumit has written on the chat window, please share some material of DSP. Okay, I will do it. Next week, we'll be going through DSP and probability theory. And then Piyush is saying, intermittent loss of signals, video may be consuming a lot of bandwidth. Yeah, that will be an issue. I would request you to get the best quality broadband signal service. That will be helpful for you because you need it. IITK has some support. So if you need some financial support, IITK can provide. Okay, next is, okay, speaker diarization. Let's say I'm talking to Sumit. So I'm talking to Sumit and I speak, hi Sumit. Sumit says, hi, how are you doing? I say, I'm doing well, how are you doing? In this way, the conversation goes on, one person speaks at a time. Okay, so which means, let's say, yeah, the conversation is going on, one person speaks at a time. Then I have this recording, the entire recording of, let's say, 1 hour of conversation. Now I want to know who spoke when. Like Vipul spoke from t equal to 20 seconds to 1 minute, 30 seconds. Then Sumit spoke from t equal to 1 minute, 40 seconds to 2 minutes, 10 seconds, like that. So who spoke when? So this is the section, Vipul spoke, then Sumit spoke, then again Vipul spoke, Sumit spoke. And it can be multiple speakers also. That is called speaker diarization. Then music genre classification. So is it Indian classical music or Western pop music, like that, genre classification. Or it is let's say, in putting in simple terms, is it Bollywood music, or is it Hindustani classical music, or is it Carnatic classical music? Like that, different genres, depending on you. Auto tagging. Auto tagging means, let's say a music is there, it could be tagged with various tags. Let's say this music has got flute in it, this music has got piano in it, this music has got sitar in it, this I'm telling example from music. This music has got Lata Mangeshkar singing, this music has got Pandit Jasraj singing. Like that, auto tagging can be done. It could be any kind of tags generated. Okay, then query by humming. Query by humming means, I think I will explain the melody estimation part first. What is melody estimation? Let's say some song is there. It has got many instruments playing. Let's say somebody is singing. On the background, there is somebody's playing violin, somebody's playing flute, somebody's playing tabla, somebody's playing drums, like that. But when you hum that music, you will be humming the main melody line. Let's say there is a song, Jana Gana Mana. Then you won't be humming the drums. You won't be humming the how the some other instrument is playing, but you will be humming what you sing, like like that. So you will be humming the melody. So how do you estimate the melody from the audio signal, which contains so many instruments playing together? This is called melody estimation. Then query by humming means, if you know the melody, you hum it, and the computer will automatically search that song for you. You hum a song, and computer will search and fetch it for you. This is the song which you are humming, right? So like that, there can be many applications. I'm just telling that these are some interesting applications. Now references. So for machine learning part, we'll be looking at PRML book, this one, Pattern Recognition and Machine Learning by Christopher Bishop. This book is available online, free of cost. You can just download and read it. It's very convenient. Then the next book is Deep Learning book by Goodfellow, Bengio, Arun Kovil. So what they do is this book is very recent, as you can see, 2016, and it tells you about deep neural networks and the current popular practices in deep learning. Okay, so this is this is also available online, free of cost. And then there are some books for audio signal analysis. These books are, they may not be available free of cost, but I think I will provide you something which you can read. Maybe some excerpts or some chapters from these books. We'll see how it goes. Okay. Then some very good articles are there. These are research papers. They're also available online. IITK has subscription to IEEE. You can download it from there, or I can share it with you, no problem. These are research articles or some research papers, like that. Some chapters from some book, like that. Okay. Okay, I think we have discussed this full thing. And all of you know, when you access the course, you see the videos here. You have these videos, the week one, these were the videos. So I think you might have spent a lot of time on learning the Python, which is good. Python is important for this course. Next, okay, announcements will be here. It will be available here. Like today, I posted this announcement Zoom link for today's class, and this link will be used for all our discussions. Then resources. I have not uploaded any resources yet, but this will be propagated soon. Forums, ask your questions here. As you can see, some people have already asked questions. Okay. Hangout, you can chat with each other, ask questions also in Hangouts. I have not used this feature as much as of now, but hopefully you all can use. On the forums, I think you can also have general discussions. You can ask your questions. This will be very useful. Instead of emailing me, or you can use this platform, and also amongst yourself, to communicate amongst yourself. You have some, let's say, some very basic questions, some very basic problems. Ask questions here. other fellow students will reply, and in this way you will learn, and I can also jump in and I can also help if some issue is there. Okay, that's it. So I think this is the platform which we are using. Let me see if you have any questions on the chat window. Okay, Shubham Shivastava. Machine learning is mainly an implementation-based course, a project-based course. Good if students do project instead of test. Yeah, we will be having a project. That is true. Projects will be good. I have written in the final evaluation, I have given 30% weightage to end sem or project. So we will see. We will see how it goes. Upload slides with video lectures. Yes, slides are also there. If you go to where course home, slides are also there. You see this PDF. This is the slides. These are the slides. And if you go to this one, this is IPNB, the Python notebook, the Jupyter notebook, which basically corresponds to this video lecture. So the slides and Python notebooks, everything is there. Please explain humming again. Humming means, let's say I listened to one song. I don't remember. I don't know the wordings. Let's say it's a German song. I don't know the wordings. Or it's a Malayalam song. I don't know Malayalam. I don't know the wordings, but I like the tune so much. I can hum the tune. And when I hum the tune, can the computer automatically find it for me? This is the song which you want. That is humming. Will you be sharing material for application of ML on image processing so that interested students can cover that part independently? Yeah, in this course, we will be doing many things which will be very relevant for image processing, like convolutional neural networks and things like that. Right. Manoj is asking noise cancellation. Could you suggest some other course which could supplement along with this course? In signal processing stream, we have got many courses which deal with noise. I deal mostly with audio noise, but there are statistical, if you model the noise as a statistical signal, statistical additive noise, then various statistical courses can help you in noise cancellation, right? You have statistical signal processing and detection estimation theory. All these courses will be helpful for noise, for dealing with noise. Will the discussion lectures be recorded? Yes. Available for use later? Yes. Is it possible to include image machine learning as well? Yeah, it will be there, but the focus will be mostly on audio. It will be there. Image will also be there. What will be the project type? Will you provide project topics or will we need to search our own? I will be providing topics. I will be floating some topics, and what I am thinking is I will select, let's say, a few topics, and everybody can jump in to tackle those problems, and there will be a competition amongst yourself. We will have shared data, shared resources, and everybody can compete with each other to improve, to basically develop good methods. So I'm not going for open-ended projects. Open projects means you choose a project and do, because just that this is the way we are going in this course. We will have a few problem statements, let's say 3-4 problem statements, and students can choose which problem they want to work on, and then they will be putting their effort towards that end. This is the format which I have chosen for this course this time. Okay, can you please refer material in short for signal processing? And there are books on signal processing, like digital signal processing books are there. Also, if you, I think next week you will see more resources on signal processing. Next week I'll be covering DSP and probability theory. Okay, next question is, how do we use Microsoft Azure Notebook? I will show it. I'll be showing it. Python coding, I'll be showing it. Don't worry. Team assignment or individual assignment? Assignments will be individual. Project might be a team project. Project will be a team project, but assignments will be individual. Yeah, image processing will be included as well. No problem. You can do that. Okay, now let's come back to our presentation. Okay, a glimpse of last year's course. If you go to this link, you can see how this course was in the last year. So this year the format will be different, but course material will be, there will be a lot of overlap in the course content. But of course, this time I'll be doing remotely, and also we'll have a project in this course. So things will be a little different, but still it will give you an idea. Okay, and we'll have lots of assignments, lots of coding assignments, and lots of, okay, and projects. If, let's see, I'm planning for a project. Let's see if we can do it. Okay, now the books I have already mentioned. Christopher Bishop, it's available online. Deep Learning book is available online. And then a very good source for learning machine learning is are the blogs and articles available online. You have a concept, you put it on the internet, on Google, it will give you so many good blogs and articles. So I will be sharing some of those blogs and articles in the resources, but you also feel free to find some. And if you want, if you find something very good, you can post on the forums in the MOOCit platform so that others can also benefit from it. That will enhance learning. Okay, now coming to coding part. Okay, on the cloud. So on the cloud, you can use Colab. It's a Google's cloud platform. So what it does is it has, you are using your computer, your browser to access it, and the CPU or GPU is running in the back end in the server, and all the computations are done there, and the results are shown on your computer screen or the browser. Okay, what is a GPU? So we have a CPU in our computers. Mostly that's what you know of. So CPUs are normally there, and one machine can have multiple CPUs, right? And for your computations, you can do parallel threading. Let's say I want to run a code, and this code has got 4 independent components. Let us say I have got, I'll give you an example. I think examples will be good. Let's take the example of speech recognition. Let's say I am transcribing some audio signals. So let's say I have got 1 hour recordings of lectures, and I have a machine learning model which can transcribe the audio into text, right? Let's say I have got 100 audio files. I want to pass this into my machine so that the machine can transcribe all of these 100 files into text. So if I have got a single CPU, I will be putting first file, the machine will transcribe it, second file, machine will transcribe it, third file, in this way, all the 100 files. But if I have got multiple CPUs, and I know that transcription of one file is independent of the transcription of the first of another file, they are independent tasks. So I can basically direct them to 2 separate CPUs. So I have 4 CPUs, let's say, and 100 files. I can put 25 files on the first CPU, 25 files on the second CPU. In this way, all the tasks can be, all the job can be distributed to 4 different CPUs. That is called parallel processing. And there are tools in Ubuntu which can do parallel processing. I have used Spark, which is a Hadoop product. In Python, it's very convenient, PySpark, but it's not easy to install on your machine. So there are easier to install things like Ubuntu has, forgot the name, some threading service, some threading thing is there. You can find out on the internet. There are so many tools to do parallel processing. basically you make a list of your jobs, and then you put you make chunks of these. The entire list you split into small chunks, and each chunk you send on a different CPU, because these are independent tasks, mutually independent. So your CPU processes them, gives the output, and at the end you again group all the outputs, and in this way you have done the same task in much lesser time. This is a parallel processing on multiple CPUs. Now, what is a GPU? A GPU is slightly different. So a GPU, basically, you can imagine there are small computation units. It is mostly used for matrix processing. You have some matrix, and you want to process it. So it has got small units sitting on the nodes, and they do the computations, and the computation becomes very fast. But the limitation is that the precision is small for GPU. All these computation units, they cannot handle very long decimal digits. They have to truncate the number of decimal points so that it is less precise. But the speed it increases so much. It is very useful for machine learning, because it is very useful for any stochastic processing. Stochastic processing means random processing, where you have some randomness involved in your algorithms. For example, let us say I'll give you an example. Let's say there is a hill, right? There is a hill, and you have to reach the top of the hill, but you cannot see. You are blindfolded. You cannot see. You can only stand, and you can feel the surface, right? So there is a hill. You are standing somewhere on some side of the hill, and you cannot see, but you can only feel what is under your feet. You can only feel the surface, right? Now I ask you, you have to reach the top of the hill. How will you do it? So so I think let us make it more interactive. You can write on the chat window, what will you do? There is a chat, okay. Okay, what will you do? So the problem is, you have a hill, you're blindfolded, and you can only feel the surface. And I ask you, you have to climb up to the top of the hill. So, and you don't know the directions. What will you do? Please write on the chat window. What will you do then? Bhavesh, very good. Move against the slope. Will check inclination, Ratnesh is saying. Anadi says, look for gradient. Okay. Himanshu says, go along the steepest direction. Very good. Manoj says, go slowly till slope becomes 0. Okay, good. Shaurya says, by measuring the gradient at that point and then move where the gradient, it's very, you're using too many jargons, but okay, fine, Shaurya. Next, anybody else, please. So what will you do? Give a very intuitive answer. You need not know any machine learning for this. Very intuitive understanding. Okay, so if I am blindfolded and I'm standing with my feet, I can feel where is higher area, where is the lower area, right? Just underneath my feet, I can feel. And now I will step in that direction, and I will feel, okay, this is a little bit higher. So this is a good direction to move in. I will proceed in that direction. Again, I'll put another step. Oh, this is again a bit higher. Then I will again move one step further in that direction. Okay, let me. So what I'm saying is, let's say, this is the top view. This is the top of the hill, and these are the. This is These are the contours of equal height. There's a top, little lower. In this way, could be any profile like this, right? And you are standing somewhere here, let us say. So what you will do, you will step in this direction. Oh, it's a good direction. But you may also step in this direction. Maybe not directly to the top of the hill, but in some other direction. Or you may also step in this direction. And then further you may go in this direction. Further you may go in this direction. Further you may go in this direction. You may go in this direction. You may go in this direction. So you may not directly reach here. You may take a longer route, but that is all right. That is all right. So you will still reach the top of the hill. So that's the idea which I want to convey, that you cannot see what is there, but you can feel what is directly underneath your feet. And based on that, you can climb to the top of the hill. So there is a lot of randomness involved because you cannot check in all the directions. You have to randomly put your foot in some direction and see whether the height is increasing or not, right? But there is some randomness involved. So this algorithm to reach to the top of the hill, it has randomness involved. Therefore, there is no meaning of using a very precise number to represent your step size or your direction. You can make your directions a little bit rough also. You don't need that much of precision here. That's why GPUs are useful in such a scenario. Okay, so GPU is basically graphical processing unit, and the working understanding of GPU is that they are less precise and they are very good for matrix processing, like matrix multiplication and things like that. And they are very, very fast, extremely fast for these matrix operations. Okay, now let's go to the next question. Okay, Abhishek is saying, please write in the center or on the left side. Okay. Shubham is saying something. Okay, Shubham, I understand your point. We will come to this point a little later about global maxima or minima, but for today's class, this is very basic. So leave it. We'll leave it at here. Okay, next is cloud. So Google Colab gives you GPUs also. GPUs are generally very costly and not easy to get, but Google provides it free for you with some restrictions, like I think some timing restriction is there. Anyways, but it is good for you. You can use. Azure has got notebooks which you can access. Let me click on it and see. Oops. Colab. I'll just open a new notebook. So basically, this is your Python notebook. I can say a. So if I run it, the variable is saved a Hari. I can say print a. You can run it by clicking this button, or you can also say control enter or shift enter. If I run it, and so it prints Hari. Simple Python notebook. Okay. Similarly, Azure, and now I want to show you Jupyter, which is done locally. Okay. So what I have is this. So what I do is I open my terminal. In Linux, you have got terminal. In Windows, I'm not sure what exactly you have. I have not used Windows for quite some time. So this is what is CD to the folder. I have installed Jupyter Notebook here. So what I'll do here is Jupyter Notebook. I write Jupyter Notebook. How to install Jupyter? It's very simple. Go to internet and find it out. I have used Anaconda distribution for Jupyter. So see, these are the IPNB files which I have here. This is a sample assignment. So basically, this is what you will be seeing in your this course. How do we do programming assignments? Okay, first I have imported the NumPy library. As you have seen in the videos, there was a video on NumPy. It's the matrix library. Okay, I will say Shift Enter, and this will be executed. Then sort in ascending. So this assignment or this problem is you have to sort a vector, and the vector is a NumPy vector in ascending order. This was the question, and write your code here, 5 marks, okay. And then you will say you have to return y, and y is that same vector, but in the sorted and with sorted entries. So I'm using this command, a built-in command, np.sort, sort vector. So in this course, you are allowed to use the functions which are defined in NumPy library, but you are not allowed to use functions which are defined in other libraries like scikit-learn library or things like that. If they are allowed, I will mention in the assignment that you are allowed to use these functions. But for NumPy, you can assume NumPy is allowed. Any function in NumPy you can use. Okay, so now this is a function, as you have known, as you have done the second lecture on Python. So these are the numbers. So okay, I want to. This is a function. I want to use this function. So I will say A is any NumPy array, and I'm printing A. Okay, this A gets printed here, and then my Y is sort in the ascending order and print Y. Okay, it's done. See, it says it's not defined, because I didn't run this cell. I have to run this cell so that this cell is executed and all the variables and functions are stored in the basically in the Python. And now this is now it is able to access the sort ascending function, and the output is given. So A was 2534, the Y is 2345, which is in the ascending order. Now this part is clear, right? You were given this problem. Write your code here, and you wrote your code here like this, executed it. It is running very well. Now you can test your code. Test your function. This is a function. I have defined a test function. How do I test sort ascending function? So how do I test it? Basically, I take a predefined vector, I pass it through this function, and now I know what should be the output. I know this is the desired output. My output should be 2345. So I can compare what your function is returning is same as what I am expecting or not, right? And I use this assert to assert that this is actually true. So I will assert that all the entries, np.all, all the entries of Y are same as all the entries of NumPy array. So this is what is the test. And if it is not true, it will throw an error message. But if it is true, nothing will happen. It will go further. Okay, let me make a mistake in this function. If I say, let's say, instead of using np.sort, I used np.sorted. Okay, this is an error, but I'm just introducing that error so the test function will be erroneous. So it gave an error. It gave an error, and you won't get any marks for this. Okay, if the error were a different kind of error, okay, let's say I used np.sort, but I'm just reversing the order so that it is in the descending order. So this is I think you have seen it in the when you say -1, it counts from the back. It reads from the back. It reads backwards. From the end it starts. Okay. So now I will test. Okay. So what this method has thrown is an assertion error. So this assert function, it failed, which means my y is not same as what I am expecting. So I have put this y. So this will tell me what exactly was that y. That y was 5, 4, 3, 2. But I'm expecting 2, 3, 4, 5, right? So in this way, if I don't put this y here, it won't show me what was the error. So whatever error message you want to print, you add here, y, comma y. I can also say, let's say y, comma, something, failed. So it will show you assertion error, it will show the y, and it will show whatever message you have shown, whatever message you want to put here. This will be printed, okay. But in our case, if I don't have this, then it says test passed, because this command runs smoothly. Then this command is executed, test passed. Okay. And similarly, this is the kind of assignments or you will be getting. So you are given a function, the name and the input and output are defined, and you are asked to write the function yourself. So for this function, input is x, which is a matrix of features, and another input is y, which is a matrix of class labels, and there are two classes, 0 and 1. And what is expected, the function should return x mean, which is the average feature for each class. And you have to return x mean. The dimensions are 2 cross f, right? An example is also given so that there is no confusion. Means I will try to make the assignments as comprehensible as possible, but if still you have any problems, you can always ask in the forum, and we will clarify. Okay, I think this format is clear. So we have functional approach or modular approach, and we have tests for each function, tests for each module. And if all the tests are cleared, the test is passed, then you get full marks. But if some test fails, then marks are accordingly penalized. Okay, I think this part is more or less clear. Anybody has any questions at this moment? Chat window. Many time collab limits uses. Students can apply for this pack. This may be useful for project. Okay, we have Jivnesh here. Jivnesh is a PhD student, and I'm sure he's not doing this course. He's just helping us. So yeah, so good point. I think Jivnesh is giving a good suggestion. Vikas, you can note it down. Okay, so which is better for complex computation, Colab or Jupyter? Colab is also running Jupyter only. It's a Jupyter notebook. Okay, but if you want to ask whether Colab online or on the cloud or Jupyter on your local machine, that depends on you. I find local machine is very good, but if your local machine is not very good, then you can try Colab also. And also, if you want GPU, then Colab is the only option you have if you don't have GPU in your local machine. Yeah, so Vikas, you can take this suggestion and put it in the, where? Put it in the, maybe in the course page, in the beginning page, the course introduction page. We can add this message there that if you want to use this. Okay. That's it. No more questions. Okay. Okay, I have already done this example in Jupyter. I am going through this. Okay, this is almost 2:56, which means almost 3 o'clock. Anybody has any questions at this point, please ask. You have any questions regarding the logistics or how we will be conducting this course? I've already told you that these resources are there. The last year's last year's link is there. All the course outlines, slides, and videos for the last year are available, and this year will be similar, more or less similar, if not exactly same. Okay. Any questions from students? How did you access last year content? Last year content is on my homepage. If you go to my homepage, go to teaching, and then here you go to 2019 fall MLSP, same course, 698V. Go to this link. This is the last year's content. And if you click on this, you will go to the slides or videos, whatever you need. How to open .ipynb files. I told you, I just showed you that you open, you can open it here. Like here you can say import, open notebook or upload a notebook. Go to upload notebook and then choose file and whichever file you need. Right, here you can open this. Notebook means ipynb. Notebook means ipynb. So you can open it on Colab or you can open locally. I just showed you how to open locally here, right? I showed you. Oh, why is this not moving away? In the home. Yeah, this is ipynb. I can open it in Jupyter, Python Basics 1. If I click, it opens in my browser, Jupyter, right? Any more questions? I would request those who are PG students, they should spend some time learning programming like Python and things like that. Then your life will be very easy. This course will be very easy for you if you are good in, if you do practice of programming now. So practice programming. How do we submit assignments? For submitting assignments, Mookit has a facility already available. Like here, if you go to assignments, it's not there yet. It seems it's not there yet. Manage course. Assessment. Last year we did it, so it's there. Just that once we do it, we will let you know. In assignments, we will give .ipnb files with questions and you have to edit and resubmit. Yes, that's what we did last year as well. Just you change the name of the file to your roll number.ipnb and submit it on that link, and that's it. Then we will be doing the assessment from our end and we will release your marks, and whatever mistakes you have made, we'll come to know. Okay. Any more questions? Otherwise, we can stop here. It's 3 o'clock now. Grading policy would be relative or absolute. Generally, we do relative grading here in IITK. So I will continue with that, relative. Okay. So thank you very much.
Thank you, sir.